Let's talk about Scala dot product. A scalar product of two vectors A and B is defined as the product of the magnitude of A, the magnitude of B, and the cosine of the angle between A and B. The basic thing you need to know here is what does it mean to have that theta is the angle between A and B. We shall have a look at that. How do we write it? We write it as A dot B. We write this as A dot B, pronounced A dot B. That is why the scalar product is also referred to as the dot product, because we are writing it as A dot B. And when you are writing the definition of the product of the scalar product is this one here, that A dot B is equal to magnitude of A. It is the product of the magnitude of A, the magnitude of B, and the cosine of theta, where theta is the angle between A and B. And now they are saying that if A and B are perpendicular, it means that theta is equal to 90 degrees, and the cosine of that theta, which is 90, would be equal to 0, and so A dot B is equal to 0. That is what we have. If theta is 90, we would have that A dot B is equal to whatever the value of that magnitude, and then you have cosine of 90 degrees. And just by multiplying this cosine of 90, we render that one 0. And when it is 0, we are having a generalization here that thus, if two vectors are perpendicular, their scalar product is 0. And the converse should be also true, that if you get a scalar product and you get 0, it means that the vectors are perpendicular. If vectors are perpendicular, their dot product will be 0. And we are saying that provided neither A nor B have 0 magnitude, it follows that if the scalar product of two vectors is 0, the vectors are perpendicular. That is some important concept which is going to be used to establish the fact that some two vectors are perpendicular. Once you get a dot product and you get 0, you just know the vectors you have got, you are dealing with perpendicular to one another. Some of the properties of scalar dot product is that they are commutative. The dot product of A dot B is the same as B dot A. This one is at least for a dot product, it is commutative. A times A is the same as A dot A. We shall have a look at these. We shall be seeing them as we move on. Maybe I can get you some example here. When let me have this vector A equal to 3 in the I plus 4j, and the A dot A is the same as 3I plus 4j dotted with 3I plus 4j, and this will get us this one times that is 9 plus 4 times 4, that one is 16, getting us 25. That is A dot A. However, if I'm to get the magnitude of A, shall be having 3 squared plus 4 squared, which is equal to 5, and the magnitude of A squared is equal to 5 squared, which is equal to 25. So the dot product of two is this one is the same as that. We have just proved this one. And once we learn how to get a dot product of two vectors, we shall be able to obtain, we shall be able to establish, we shall be able to prove these properties here. We'll be able to prove all these properties here. Let us proceed. We shall be understanding them. So we have some examples here. Find A dot B for each of the following. So one of them is A, one of them is B. So if this is A and this one is B, we are saying that A dot B is equal to magnitude of A times the magnitude of B times the cosine of theta. And now the magnitude of A in the first case, we have 8. This one is 8 times 60 times cosine of 50 degrees. When you work out there, we are going to get 30.9, just like that. 30.9 is the dot product. That's what we have there. Then number 2. Now for this one, when you have this 60, the 60 we have here is not the angle between these two vectors, because if this one qualifies to be, for this one to qualify to be the angle between the vectors, they must be coming from a common point or entering a common point. But now when you look at this one is towards this one is away. So this is not the angle. So what we are supposed to do, we shall extrapolate this one. Extrapolate that so that it goes into that. And so the angle between the vectors is this one, which is equal to 120 degrees. So that you have them in the same direction. Not the same direction, but in the same sense. From a common point, both of them should be either into or away. So both of them are, by having this one go that side, I have this one now, I have that this one now, the forces, the vectors are away from this point here. And so this is the four units. And so we shall have that A dot B is equal to 5 times 4, and the cosine we're supposed to use is not cos 60, but cosine of 120, because the angle between these two vectors is 120. So we shall have cos of 120, that one is negative, it is negative half, then we shall have this one as negative 10. That's what we have. The same applies to this part C here. If you are to get the dot product of this, you extrapolate that so that it can go there, and the angle between the two vectors is this one here, which is 180 minus 30. So this is 150 degrees. And A dot B now shall be equal to 10 times 8 times cosine of 150 degrees. This is 80 times negative root 3 over 2, that is the cosine of that. And we have the final answer as negative 40 root 3. That is what we have as the dot product of these two. Then here we have these ones are, both of them are from this point away. They are both of them away from here. So they should be, actually the forces should be radial, should be moving radially. Then the angle between the radial forces will be, the required angle, will be the angle. But if one of them is into and one is away, then you must extrapolate the another one, so that the other one, so that you can have them in the same and moving radially. So around here, this one is in the format, the one we are supposed to use. It is in the format jebalagire. So we shall have that A dot B is 6 times 15 times cosine of 70 degrees, and when you press the calculator here, we have 30.78. That is what we have there. Now we have some unity vectors for I, J, and K. For unity vectors I, J, and K, they also have their dot product. You can dot them, you can get their dot product. So when I have a unity vector I and I get it dotted with I, what do I get? Remember the definition of a dot product: magnitude of the first one times magnitude of the second one. Remember, a unity vector always has magnitude 1. Then times the cosine of the angle between the two vectors. If you are having I and I, the angle between it is like this. You have I, and then unity vector there is J. The one for the I, for the y-axis is J. So with that, you see that I and then J, you realize that when you have I dot I, both of them will be along the horizontal, so the angle between them is 0, and the cosine of 0 is 1, so basically that is 1. When I have I dot J, I get the same answer as when I get I dot K, and that one will be unity vector for I 1 times unity vector for any other vector 1 times the cosine of 90 degrees, because I and J, the angle between them is 90. So you have the unity vectors, the unity magnitudes 1 times 1, then cosine of 90 equal to 0. So from here you see that once you have them different, I dot K, you have I dot J, you have K dot I, remember K dot J, remember they are commutative. So we have this. For those ones which are similar, I dot I, you get 1. J dot J, you get 1. K dot K, you also get 1. But the moment you have a mix up of those unity vectors, I dot K, I dot J, you have K dot J, all of those ones get us, all of those get us, they get us a 0. So the summary is here. It is also in your notes on our Telegram channel. You can get through them, and we shall be getting through them. You will be having more understanding of the things when we come to when we do more examples. We have this statement here that suppose you have this vector a1, a2, a3, and b is equal to that. Then a dot b is equal to this. You just get the i's, multiply them, plus the j's, plus the k's. Because if you work out properly, you are supposed to open the brackets here. This one, you have this, multiply by that, and you get a1, b1. But I dot I, you get 1. Then you have this one times that. But now when you have I dot J, that one is 0. I dot K, another 0. J dot I is 0. J dot J, that's how we get this A to B2, because J dot J is 1. Then A3, K, times b1i. Once you have the k and the I, that one is 0. Then a3, you have k and j, that's another 0. a3, b3k, that is the one which gives us this one there. So you have that a dot b is given by that. And you're also observing that the scalar product of two vectors gives a scalar quantity. That is what we can say about a scalar product. We have an example here. They are telling us that if a equal to that and b equal to that, find a dot b. A dot b is got by getting 4i minus j plus 2k dotted with 3i plus 6j plus 7k. And what I do, I get the i's. 4 times 3, that is 12, plus multiply the j's. -1 times 6, that's -6, plus multiply the k's. 2 times 7, that one is 14. And at the end of it, I have my final thing as I have 12 minus 6 plus 14. This one is should be 20. That is the dot. That's the dot product. Another person can do it like does it like this. You get 4 -1. This is -1 2. Then dotted with 3 6 7, and then you get the final answer as 4 times 3 plus -1 times 6 plus 2 times 7, which is equal to 12 minus 6 plus 14 equal to 20. That is you just multiply out this one times that, this times that, this times that, plus this times this, plus this times that, and you are there. That is the dot product. Yeah, that's the dot product. Find a dot b, given that we have that. Now a dot b is equal to 2i plus k dotted with 3i minus j plus 4k. When you work out with this, the i's, you have 2 times 3 plus the j's, 0 times -1 plus the k's, 1 times 4. You don't put the 4 because you can see that when I get I cross I dot I just get 1. I get 1. So the j's, the product, what you get as a result of a dot product is always not a vector. And you can see that it does not bear the i's, the j's, and the k's because it is not a vector. It is just a scalar. This one is 6 plus 0 plus 4, getting us 10. So you have that a dot b is equal to 10. That is dot product. This example is saying that find the angle between the vectors a equal to that and b equal to this one here. Now here we are going to use the definition of a dot product. We know that a dot b is equal to magnitude of a times magnitude of b times cosine of theta. So you have that cosine of theta is equal to a dot b divided by magnitude of a times magnitude of b. So what we need to do here, we need to get the cosine, we need to get the dot product, and also get the magnitudes of the individual vectors. So we have, first of all, we shall get the dot product. A dot B is equal to 3.5 2 3 dotted with this one is 2 negative 6 5 over 3, and we shall have 7 minus 12 plus 5, which is equal to, we are getting a 0. So here we are having that the dot product is already 0, meaning that they said find the angle between them. So it means that theta is equal to 90 degrees, because we saw that once you have that theta is 90, that is the only way you can have that the angle between the vectors is 0. Once you have the dot product equal to 0, you know the angle between the vectors is 90 degrees. So this is our dot product, it is 0. That one is an indication that the two vectors, this and this one, they are orthogonal. They are perpendicular to one another. That is what we have there. Example 4. Find the angle between the vectors I plus 2j plus 3k and 3i minus j plus 4k. So we shall say let one vector be equal to I plus 2j plus 3k, and then another vector b equal to 3i minus j plus 4k, such that now we need to get the dot product, which is I plus 2j plus 3k dotted with 3i minus j plus 4k. The i's, you just get 1 times 3, that one is 3, plus multiply the j's. The i's are giving us 3, this I, this one times that. It is that you get I dot I, then the 3. So you get just I dot I is 1. So there you get just a 3. And then for the j's, we have negative 2, because we have 2j times negative 1, the coefficient of j there. Then the k's, we have 3 times 4, which will get us a 12. And at the end of it, we have this one as it is 13. That one is 13. We also need to get a magnitude of a is square root of 1 squared plus 2 squared plus 3 squared, which is equal to square root of 14. Then magnitude of b is square root of 3 squared plus negative 1 squared plus 4 squared. That one gets us, this one is 16 plus 9, that is 25, plus this one, that is 26. So we have root 26 there. And now, from the definition of a dot product, we shall get that cosine of theta is equal to a. Actually, it's supposed to be that cosine of theta is equal to a dot b divided by magnitude of a times the magnitude of b. A dot b, we got 13 divided by root 14 times root 26. That is what we are having there. And we have actually we have that let me get some shape here. I create some space. Oh okay, create some space here. So you can ably say that theta is equal to cos inverse of 13 divided by square root of 14 times 26 is 364. And theta itself here, if I work out that, I get 47 degrees. That is the angle between the given vectors. You get, if you want to get the angle, get the dot product 30, which is there. Get you get the magnitudes of the different vectors and substitute in the formula. The formula is got from the definition of a dot product. That is the one which is getting us that value there, those values, and there we are. Oh, there is another question here for which I didn't leave space, but I can put it here. They said find the angle between, this one is A, which is equal to 2I minus J plus 3K, and then B is the vector I plus 4J plus 3K. Find the angle between these vectors here. So let us get the dot product. A dot B is equal to 2I minus J plus 3K dotted with I plus 4J plus 3K. And as we saw, you just look at those, multiply those ones which are corresponding, and you are there. So the I's, you have 2 plus the J's, -4, plus the K's, that one is 9. When you work out everything here, you are going to get that one should be 7. It is it 7? Yeah, it is 7, because this one is 11 and then -4, that is 7. Then we need to get A, magnitude of A is square root of 2 squared plus -1 squared plus 3 squared, which will get us a value equivalent to, should be 14. That value is 14, because this one is 9 plus 4, 13, root 14. Then magnitude of B, I get square root of 1 squared plus 4 squared plus 3 squared, and that one is 26 under root 26. And from the definition of a dot product, we have that A dot B is equal to this one times cosine of theta, where theta is the angle between the vectors. A dot B, we got it as 7. It is equal to root 14 times root 26. Root 26 times cosine of theta. And the implication of this is that cosine of theta, this one here will get us what I'm going to write here. Cos theta is equal to 7 over square root of 364. And we further have that theta is equal to the cos inverse of 7 divided by square root of 364, and we further have that theta is equal to 68 degrees to the nearest degree. That is the angle between these two vectors here. The angle between these two vectors is 68.